Hello, good morning. So, today we will go through a very short lesson, but still important. So, the topic of metals. Metals. Because why? Because it totally matters. Haha. Anyway, let's start. So, we'll be focusing on the physical properties of metals and alloys, which honestly to me is something quite a giveaway, quite a standard things that they always ask. Okay, so we will start off by we remember we learned this thing called metallic bonding. Yeah, metallic bonding, which is essentially cations in a sea of delocalized electrons. And the forces of attraction is your strong electrostatic. So recall, electrostatic means there's opposite charge. You have cation, which is positive, electron, which is negative. So the new property is there's this thing called alloy. So you also need to know the definition of an alloy lah. Not that they always ask, but it can be tested. So alloy is a mixture. It's a mixture of a metal, at least metal, and one other, and at least one other element. Sure, there are elements out there with plenty of there are alloys out there with plenty of elements, like up to what 7-8 different elements in the alloy. It exists, but minimally you need to have a metal and one other element. Oops. Which means you need to be able to draw the diagram. So this will be oops. This would be a pure metal. So what happens is it is essentially it looks like logs, like tree logs, timber that is in one row. They can slide over each other quite easily. So what happens when you have a force? You use a small force. It will move lah. It will now be like this. It has moved. So this is called slide over easily. So that is metal. In a metal is quite homogeneous. It's quite the same in that sense. But what happens in an alloy? So you need to be able to draw. They can ask you. So if it's an alloy, what I will do is something big inside. Something big inside. So in this case, when you have a force, it does not slide over easily. Essentially, there are things to block it. So you need to put this into an explanation. So it's quite actually honestly this is a very standard question lah. Explain why pure metals are soft while alloys are hard or strong. Stronger. So this is quite a standard 2 marks question. You can check your O-level paper or your exam paper. It comes out almost every single time. So I will start off by telling them that For pure metal, I'll tell you why is it soft first. There are little force, minimal force lah, is needed to cause the regularly arranged layers of atoms to slide over each other. Therefore, it is soft. However, for alloys, so there are some keywords I'm looking out for. So I need you to write this: atoms of different element. So is the thing that's a different element that's a problem? But not just different element. Different element also means different size. Different element of different size. And the D word, disrupt the regularly arranged layers of atoms. So, therefore, it is harder. That's all. It's quite a standard 2 mark, but nevertheless, it's still 3 marks. Yeah, that's the main thing about alloys per se. Okay, next we'll move on to chemical reactions. So there is a total of 7 reactions in this topic. Yeah, I'm quite sure at this point you were like, huh? 7? Oh no! How to remember? How to do? But honestly, don't need to worry because almost all of this reaction, right, is based on this idea of displacement. So my comfort for you is as long as you know the idea of displacement and you know your reactivity series, the 7 reactions would not be scary. So let's talk about the reactivity series. Which is something that you may not have remembered, but now you need to memorize it. So it is P, which is potassium. Please stop calling me cute zombie. I like please stop calling. You, by all means, go ahead. You can actually think of your own mnemonic. Yeah. Calling me a cute zombie. I like. So this is the reactivity series. So out of the 7 reactions, not all 7 reactions are new. Some of the 7 reactions we have learned before already. So for today, we are just gonna focus on 2 reactions. The first reaction that involves a metal, which is acid plus metal. which you learned before. First reaction, acid plus metal. We learned that before. So it's merely a recap at this point. So you see, an acid, let's say we have HCl. Oh, HCl. You notice there's a H. H is here. So that, and remember the idea of displacement, which is a more reactive, kick out a less reactive. That means, technically speaking, it must be more reactive. It must be higher up. So if I were to highlight, right, for this reaction, only metals that are above hydrogen can react with metals. Sorry, can react with acid. So for example, zinc, oops, wrong color. So zinc is the more reactive. Zinc kick out the H. So now you have zinc, Cl2 plus H2, then we balance it. So this is the first, which is the basic reaction. Second reaction is actually very generic. What do I mean? As long as it's a more reactive metal plus a less reactive metal compound. Super generic, meaning it could be a solution, it could be like a copper sulfate. Then you add a piece of zinc. It could very well be like copper oxide plus again zinc. They will react, although maybe some of them requires heating lah. So first one, copper sulfate plus zinc. Zinc is the element. Zinc is here. Copper is here. Oh, zinc is above the reactivity series. Zinc is more reactive. So zinc will kick out. So now you have you have Cu that's kicked out. And zinc will take its place, zinc sulfate. That's it. But of course, for this topic, they will love to ask you to describe the observation. So the observation in this case would be, you have copper 2 sulfate, which is blue solution. You get zinc sulfate, which is a colorless solution. There is your first answer. Blue solution turns colorless. So when metals are formed, it is typically in our mind silver, but actually in real life, right, it's not that nice. Usually it is gray. However, there's a special metal. Copper is actually a reddish brown solid. So you notice I used the word solid. I didn't use the word precipitate. Precipitate is referring to a compound. So reddish brown solid formed. Yay. Okay, next. Copper 2 oxide and zinc. Oh, zinc is more reactive. So you zinc oxide plus copper. So these reactions still take place, but you notice everything is a solid. And we know that solid can react one meh? Can is can lah, but you may have to melt the solid or at the very least heat it to a high temperature. If not, the reaction may be very slow lah. But it can still react. You just need to help it, give it a boost. So in this case, the observation will be, okay, copper 2 oxide is actually a black solid. Zinc oxide is a white solid. Okay, so in this case, you don't need to worry. Usually, we will ask you for the observations regarding solutions. Yep. Yeah, so that's about it. That's these two reactions for today, plus the properties of an alloy. So something easy to let you digest. Yep, that's about it. Thank you. Bye bye.